Hi everyone, John here from First Frame Photography. For a while now, DeepPRIME XD3 has been the engine Fujifilm shooters have bragged about. DxO's most advanced noise reduction and detail extraction technology, but locked to the X-Trans sensors only. If you were shooting Canon, Nikon, Sony, Panasonic, or basically any other Bayer sensor camera, you were stuck one tier below. That's changed. DxO PureRAW 6 and PhotoLab 9.6 now bring DeepPRIME XD3 to Bayer sensors, which, by the way, covers roughly 95% of all digital cameras on the market today. This is a big deal, and in this video, I want to go past the marketing headlines and all the hype and actually show you what changed architecturally, when you should use XD3 versus DeepPRIME 3, and how to read the ISO thresholds, how to spot and fix the one artifact you need to watch for. Doesn't show up very often, but you need to be aware of it, and how to slot this into a Lightroom-centered workflow without doubling up your corrections. This is a complete guide. So grab a coffee and let's get into it. Okay, so in this video, I've got 4 sections that I want to talk about. Section 1, what actually changed under the hood. Section 2, DeepPRIME 3 versus DeepPRIME XD3, when to use each one. Section 3, ISO thresholds and the luminance slider. It'll be a fun one. And Section 4, that hazy boundary artifact that I mentioned earlier and how to fix it if and when it does actually show up. All right, let's get going. So Section 1, what actually changed under the hood. Let's start with the architecture, because understanding this will make every decision later in the video make sense. Every raw file from a Bayer sensor camera arrives with 3 fundamental defects: a color mosaic, the Bayer pattern itself, sensor noise, and lateral chromatic aberration introduced by the lens. Previous DeepPRIME generations handled denoising and demosaicing jointly, but chromatic aberration correction was always a separate upstream step. DeepPRIME XD3 folds all 3 corrections into a single convolutional neural network. I know, big words. The idea is that the same feature maps used to detect edges for demosaicing also help distinguish signal from noise. And the same spatial context that spots lateral color shifts also improves demosaicing accuracy. Training these together produces a more efficient result than running 3 separate networks in sequence. To give you a sense of scale here, DxO evaluated roughly 50 different neural network configurations, each trained for about 3 weeks on some really powerful computers. I guess what I'm trying to say is that after all of this work they've done, they've been able to keep the processing time from previous iterations of DeepPRIME unchanged, not adding more time to your workflow. Looking at the schematic or diagram that I'm showing you here, I think this explains everything visually for you. Before we go any further in this video, I'd like to mention that I am actually an affiliate of DxO. What that means to you is that if you use my affiliate link, which is in the description below, you will get a discount if you decide that you want to buy the software at no extra cost to you. That being said, let's move on to the next thing I want to mention to you, and that is, with this video, I have a companion PDF for those of you that like to read as well as visually watch videos, and that is linked in the description below as well. And I have one more thing I want to just give you a little bit of a teaser of, and that is this little app I've got for you guys. Again, this will be linked in the actual PDF that is linked in the description below. And this app is, get this, it's a Bayer sensor denoise and detail simulator. Very cool. I think you're really going to enjoy that. But now let's move on to the next section. In section 2, I want to discuss DeepPRIME 3 versus DeepPRIME XD3, when to use each. Here's the part that actually matters for your day-to-day workflow, knowing when to reach for XD3 versus the standard DeepPRIME 3 engine. Think of DeepPRIME 3 as your everyday cleanup tool. It's fast, it's predictable, it delivers a dependable mix of noise cleanup and detail retention without pushing the image towards an over-processed look. For well-exposed files at low to moderate ISO settings, large batches, or anywhere natural rendering matters more than maximum extraction. DeepPRIME 3 is exactly right. DeepPRIME XD3 is your emergency room tool, if you will. It uses a larger neural network and more aggressive modeling, and DxO cites roughly 2.5 stop improvement in perceived noise reduction over standard DeepPRIME. You reach for XD3 when the file itself gives the engine something worth saving. Low-light wildlife, indoor events, night scenes, anything heavily pushed in post. One important nuance to make note of: XD3 doesn't improve every image by the same amount. On a clean, low ISO file, the difference between DeepPRIME 3 and XD3 can be modest. On a heavily stressed high ISO file, the improvement is obvious. That's why I don't treat XD3 as a permanent default. It's a higher ceiling option for images that justify the extra processing time. In this section, I want to talk about ISO thresholds and the luminance slider. Let's just talk numbers for a second. The crossover point between DeepPRIME 3 and XD3 isn't purely about ISO. I hope that kind of makes sense a little bit, but here are some practical starting thresholds. ISO 100 to 800. XD3 is still preferred if your lens shows chromatic aberration, since XD3's integrated chromatic aberration correction closes a gap DeepPRIME 3 can't. If throughput matters, and what I mean by throughput is, as an example, batch processing, where time matters, DeepPRIME 3 is faster. The next is ISO 800 to 3200. Don't forget, these are just general guidelines. XD3 starts to clearly separate itself as luminance noise begins interacting with fine textures at these ISOs. For ISO 3200 to 6400, the difference becomes clearly visible at 100% view on a 4K display. ASPC sensors, crop sensors, show this split even earlier, around ISO 1600. That all has to do with the technology behind sensor sizes, and if you want me to create a video explaining the difference between sensor size, I can do that for you. Just leave it in the comments below. Next, we're going to go a little bit higher, and we're going to go up to 6400, and you can see what I'm going to talk about now in the images that were in the previous section of the football game at night. ISO 6400 to, going all the way up to 25,600, XD3 delivers roughly a 3-stop noise improvement. But this is where you need to start watching for that hazy boundary artifact that I'll show you in a minute. ISO 25,600 and beyond, XD3's reconstruction can occasionally overinterpret noise as signal. Test both engines, meaning DeepPRIME 3 and XD3. DeepPRIME 3 sometimes produces more natural gradients at extreme ISO settings. Now comes that nice little app I told you about. This is just amazing. Rather than show you on images, which I did earlier, I'm going to show you with this little app that I've got for you. So let's take a look at this guy. The luminance slider, which defaults at 40, is your primary tuning dial. Lower values around 10 to 25 retain film-like micro texture, which is great for portraits and skin. The 30 to 45 range is DxO's balanced default for most subjects. That's why it defaults at 40. Above 50, you're applying stronger noise suppression, which would be appropriate for ISO 6400 and up. And above 65, you're in maximum smoothing territory. Just watch out for waxy skin rendering if you push that too far. One thing worth remembering, if you plan to lift shadows significantly in post, a full stop or more, XD3 becomes beneficial at much lower ISO values, potentially even ISO 64, because shadow lifting amplifies whatever luminance noise is present. I'm sure you've all seen that. You can actually download or get your hands on this when you download the companion PDF. The link for this will be in that PDF, which is all in the description below. So here is the DeepPRIME XD3 Noise Lab Bayer Sensor Noise and Detail Simulator. That's all it is. It's just a simulator. It's for educational purposes only. But if you take a look over on the left-hand side here, we've got capture and settings. Simulates the DeepPRIME XD3 denoising and demosaicing panel. So here we go. We've got a variety of different ISO settings and a variety of sensor resolutions. And I'm leaving these guys at 3200 and a 26 megapixel sensor. As you can see down below here, the default is at 40. And if we reduce this, we'll retain some of that film-like texture I mentioned earlier. And if we increase this, then we're going to be reducing more of that potential detail, which is why we have a forced detail slider as well. So what we need to do is try to find a balance for our images between reducing the amount of luminance noise and retaining some of the detail that's important to us in those images. These are only starting points, but this is a great tool. We've got the grain versus detail trade-off scale here. Read all about it. Stair-step artifact threshold, read all about it, play with it, keep your eye on the details, if you will. What I'm going to do is I'm just going to slide down here a little bit, and I'm going to bring up this visual here. Since we're all visual artists, this will make a lot of sense to us. We've got this image here. We've got an explanation down here for what each one is all about. We've got the various ISO settings. So if I was to click on, say, 6400, you can see 6400 will natively introduce more luminance noise. If we go down to 1600, we have less. So let's stay with 3200. And what I'm going to do is I'm going to move this luminance slider back and forth so you can see what's going on. If I take the luminance slider value completely off, this is the noise that would be in your digital file without any noise reduction. Then, if we come out to, say, about 20, 25, we're starting to smooth things out, but we're still holding on to some of that luminance noise. If we go up to the default of 40, we can see things are getting a little bit softer. Green here indicates that we're still clean and safe to go with that. And if I raise this a little bit higher, we can see that even at 60, we're reducing more of the luminance noise, but we're also losing a little bit of the edge detail. See there? Edge detail, losing it. And that's where the forced detail slider would come into play. Let's move this up a little bit higher. And if I go all the way up to here, the luminance noise has been reduced, and the simulator here tells us that we still have a clean file, but I'm not convinced. Let's come over here and do that. Oh, look at this. So now what we're doing is we're bringing up our forced details, and I found that in this instance, around 28, we're still good to go. And as soon as we go to 29 or 30, now we're in mild false texture. And you can see that in here. If I move this over a little bit more or just go to the extreme, you can see how we're introducing all kinds of goofy artifacts and everything else. If I was to pull back on this and bring this down to the default of 40, forcing the details is forcing the details. Severe plastic artifacting. So let's bring this back down, and you just play with this to come up with something. Gives you a visual idea. Learn this, and then when you're actually working with the application, whether it's PureRAW 6 or PhotoLab version 9.6 that has the XD3 engine in it, I think you'll be able to use the tools a little bit better. So that is all that I want to say. And then down here about this tool, this is an interactive teaching model for DeepPRIME XD3 decision making. It uses synthetic Bayer sensor sample data and heuristic thresholds. It is not DxO's proprietary algorithm and does not reproduce exact XD3 output. Luminance and Force Details use normalized teaching scales. Exact UI ranges may vary by DxO products and their versions. The slider details Luminance 40, Force Details 0 reflect PureRAW 6 and PhotoLab 9.6. That's the disclaimer. This is not anything that DxO has put out. Something to learn with, something to play with. In this section, which I'll call Section 4, the Hazy Boundary Artifact and how to fix it. I know I mentioned this to you earlier, and I'm going to try to show it to you. In my investigation on all the things that I'm talking about in this video, I came across this one article that was dealing with a hazy boundary artifact that XD3 sometimes creates at high contrast edges. So in this image here, you can see where the jersey has the dark, actually it's a black jersey, but I've lightened this image up so much you can tell by the skin tone of the hockey player and the lack of detail in the white part of the jersey. I've lightened it enough to hopefully try to show you this, but I'm not quite sure I'm going to be able to do that. I'll bet you anything, if anybody out there has a 4K monitor, and I'll have one of those one day soon, you can probably see what we're talking about. So what I'm talking about, and you can see with the cursor here, is right along the edge where the light meets the dark. It looks a little bit different than it does up here. It's a little bit smoother. And what happens on occasion, XD3 can produce a visible hazy boundary zone, a thin band where the denoising looks softer on one side of the edge than the other. Trying to show this to you. I've got another image. I'll see if I can show it to you there as well. It's also noticeable on light skies and dark tree branches. So I'm just trying to show you with this image, and right along this edge where the dark branch meets the light sky, we have this softening. This happens because the neural network uses local context to classify pixels as either detail or noise. And at abrupt tonal transitions such as this, it can misclassify the edge that it's looking at. So there's a couple of things that we can do to reduce that, and I'm going to try to show it to you. I'm showing you these guys, these first two images. Well, the first image I showed you is a high ISO image that I was underexposed and I really had to try to lighten it, and I think you can see that edge right there. In this second one, this is shot at probably ISO 200, and I'm not sure if it's really showing up or if my eyes are deceiving me into believing it's there. I'm trying to show it to you. I'm also going to try to tell you that, or at least I want to tell you, that this may not happen on any of your images. And I think not only does it depend on the high contrast edges in your image, I think it's also going to depend on the sensor that you have in your camera and whether or not you've got a 4K monitor that you're looking at stuff, which apparently 4K monitors have much more, or show much more detail in their images. But anyways, let's go on. In this example, I'm bringing you into DxO's PhotoLab 9.6 to try and show you where that edge is. So I've got this image, and the reason why I'm using PhotoLab is because if you take a look down at the thumbnails in the bottom area down here, you can see that the image is drastically underexposed and the white balance at the time of shooting this was off. So I'm using DxO to lighten the image, and I'm using DxO to adjust the color balance, something that you cannot do in PureRAW 6. So that's why I'm doing it here, so you can actually see this happening in here, knowing that DeepPRIME XD3 here and in PureRAW are identical. So I have the default luminance setting at 40, and I have force details set at 0, and I've got this loop guy here that we're looking at to see this, and I've got it set at 200 view. If I had it at 100 view, it'd just be the same as looking in the window because I have the image at 100% view. But if you look at this edge here, I think you can see that there's a little bit of softening stuff going on here, whereas there's a little bit more detail up here and on this side. I'm hoping that you can see that. But anyways, if you happen to see this in your image and it bothers you, this, believe me, will not bother me at all, especially if I go press print, just by what happens when you put ink on paper. What we need to do is we need to lower the force details slider, and we can lower it down to -20, and we can try putting it down at -40 to see if this can apply a more conservative model that treats uncertain boundary zone areas as noise rather than signal. Anyways, whatever. Let's just see what we can do with this. If that doesn't work, and if the haze is mainly in the shadow side, try lowering the luminance from anything that is above 55 or 60 down into the default zone. I didn't push the luminance on this image up any higher because this is smooth enough. And if I raise the luminance noise reduction up even higher, then this is going to start to look plasticky. I'm not sure how many times this is going to work on or show up on any of your images. If neither of those adjustments resolve it, then simply just go back over to DeepPRIME 3. And at that point, if I come over here, and I'm not going to play with the sliders, I'm going to let you experiment with your images with that. But if we come over here to DeepPRIME 3, leaving these guys at their defaults, we can see that DeepPRIME 3 did not remove as much noise in the shadow areas as DeepPRIME 3 did. So you might want to increase the luminance noise reduction. And let's just move it up a bit. Let's go up to, say, 60. And got rid of a little bit more. If you want more of it gone, then you go up to 80. And you can see how it's starting to smooth out. So there's always a workaround for this kind of stuff. Another one of the new features in PureRAW 6 and in PhotoLab 9.6 when it comes to saving out your files, DxO has come up with a high fidelity DNG compression. As you remember, if you were using PureRAW 5 in any iteration of version 5, when you saved or exported out your file, your, in this case, NEF file, as a DNG, we ended up with a really, really bloated file size. Just to give you an example, this NEF file from this particular camera resulted in a 17.3 megabyte file. If we went and exported out in the previous versions, and in this version, you can go and do the uncompressed, but now we have the option to have a compressed high fidelity DNG. Let's see what the uncompressed file size would be. So we come over here and take a look at this, and we can see that we went from 17.3 to 48.1. And that's substantial. It's what, 3 times? 2.5, 3 times? 17, 34, 48, 2.5 times. Now we have the option of using the high fidelity DNG compression. And that, most of the time, if not all the time, ends up producing a file that is smaller than the original camera RAW file with no perceived loss of quality. So let's just take a look and see what that would do with this image. So now we're at 14.9. Remember, when we first came in, this one was 17.3. Now we're just under 15. That's huge. And this is probably what stopped a lot of people in the past from wanting to use this because of the bloating of the uncompressed files in the past. Not anymore. Use the hi-fi, what we call hi-fi, but it's actually high fidelity DNG, and you'll end up with a lot more space on your hard drive. If you're using Lightroom as your main editing piece of software, then once you are done with using PureRAW 6, you're brought back into your Lightroom workflow, if you will. One of the things I need to highlight to you is that you need to turn off all options in the detail panel and all options in the lens correction panel. Right now, I have the high fidelity compression DNG selected in the window here. And in the detail panel, you can see back in Lightroom, I want you to go over to the detail panel, and I want you to make sure that all the options in the detail panel are turned off. This up here is the AI noise reduction part of Lightroom. Down here is the sharpening. Turn that off completely. Set the amount to 0. Down here is the legacy manual noise reduction. Set that to 0 as well. And I'd also set the color noise reduction to 0 just to be on the safe side. Notice up here in the AI noise stuff, we have an alert triangle. And if I click on that, you'll see a little alert box that says that the raw details panel is not compatible with this photo format. Just click OK. Boom. In other versions of PureRAW, like maybe 5, you may not get this alert box that automatically shuts that down completely. So if you don't, just come in here and make sure that just make sure that that's not selected, so you're not going to do any double processing. The other thing that you need to make sure that you have set to nothing, off, zero, zipple, zilch, whatever you want to call it, is your lens corrections. Under, well, we have profile and manual, it doesn't really matter. Keep these guys off. Make sure there's nothing selected in here and you don't have these guys checked. That way, you're not going to double process your files, which will end up ruining your files. So that's the complete picture on DeepPRIME XD3 for Bayer sensor. The unified 3-task architecture, when to choose it over DeepPRIME 3, the ISO thresholds that actually matter, how to fix that hazy boundary artifact if you ever come across it, and how to slot it cleanly into a Lightroom workflow. If this saved you some trial and error, hit the like button. If this saved you some trial and error, hit the like button. If this saved you some trial and error, hit the like button. It genuinely helps the video reach more photographers who are wondering whether XD3 is worth it on their gear. I believe it is. Subscribe for more deep dive breakdowns like this one, and if you want the full written reference with every decision table and settings chart from this video, I've got a complete written guide. Link is in the description. Also, don't forget about the DeepPRIME XD3 Bayer sensor noise and detail simulator that I demonstrated earlier in the video. The link for that is in the companion PDF, and that PDF is linked in the description below. Let me know in the comments what camera you're shooting with and what ISO ranges gives you the most trouble. I read every comment and it helps me pick up the next test case. Thanks for watching, and we'll catch you in the next one.